Okay, guys, greetings once again, and welcome to another edition by iCampSA. In this edition, we're looking at the 2025 November exam. This is the paper that was written nationally. Our focus will be on question 2, which covers statistics. So let's go ahead and have a look at what they were expected to do the class of 2025. So question 2 reads, the cumulative frequency table below shows the amount of time people spend on a particular website on a certain day. So what I need you to note, what is given here is cumulative frequency, not frequency, okay? And we're given as it is, and we are asked for the first question, how many people visited the website? So remember, whenever you're dealing with cumulative frequency, whatever the last number is, it becomes your total. Okay, so let's go ahead and answer 2.1.1. So with 2.1.1, we can give the answer, which is that the total number of people who visited the website, of people who visited the website is what we can see there, is 70. Okay, so that becomes our answer for 2.1.1. Very easy. Now let's go to 2.1.2. 2.1.2, we are asked how many people spent more than 40 and up to 80 minutes on the website. So if you look at our times, 40 belongs in this range and 80 belongs in that range. So what we'll do is we'll subtract the numbers, 64 and 40. Okay. So if you observe carefully, you can say 64 minus what? 40. And what we are going to get is 27. Okay. So what we can say is that 27 people spent a duration or a duration between the given times there. So they spent a duration that is between 40 and 80 minutes on the website. Okay, so very important, guys, and very straightforward. So done with 2.1.2, we can now go to 2.1.3. So we are required for this question to draw the histogram that represents the information provided in the cumulative frequency table. So what we are required to do is to go and draw the histogram. But what I need you to remember is something that is very important, guys. And that is for the histogram, we require the frequency, not the cumulative frequency. So for the histogram, what we need is the frequency and not the cumulative frequency. So we don't plot the cumulative frequency, we plot the frequency and not our cumulative frequency, because that is what we are given. Okay, so you just need to be wary of this. So what I'm going to do is to quickly draw the table so that we figure out the most important question, which is how then do we find the frequency given cumulative frequency? So what we are going to have is our time, and then we are going to have our frequency, and then we are going to have our cumulative frequency. So let's create some space here. So we're going to have our cumulative frequency. Okay. So if you look at the times, they all start with zeros, but I'm just going to adjust them so that they make more sense. Because if you think about it, if between 0 and 20 you have 16, and now we are saying 0 to 40, so it means from 20 to 40, that is where you actually have the difference, which is the 40. Not sure if that does make sense. But yeah, this was supposed to be written this way. So you have 0 up until 20, then we have 20 up until 40, and then we have 40 to 60, and then we have 60 to 80, then we have 80 to 100. Okay. And then we'll quickly note down our cumulative frequency, which is, let's just move one more down. So if you look at our cumulative frequency, that is 16, and then 40, then 59, and 67, then the last one becomes 70. So what I need you to remember, we've done a lot of maths before. Whenever you have frequency and your cumulative frequency, the first point will always be the same. Okay. And then how we get the next ones, remember, you would usually say 16 plus the number that is here, that will give you 40. So in other words, what that means is we just need to do 40 minus 16. Then what you get is the number that is there. Okay. So if we go ahead and we say 40 minus 16, what we end up getting is 24. Okay. We get 24 there. And if you think about it, you would say 40 plus some number, and that would give you 54, 59, which means all what you need to do is to do 59 minus 40, and you get whatever that is there. So what we are going to have is 59 minus 40, and we get 19. Okay. So we get 19. And then we do exactly the same. Take this, you minus there. So you have 67 minus 59, and what you get is 8. So we get 8 here. 8. And then if you observe carefully, we go and do 70 minus 63, which will give you a 3. So we get 3 here. How did we get that? We just took these and we just subtracted them. Okay. So yeah, that is what we did, guys. I hope it does make sense to you all. So that is just what we did. So I'll just put the subtract just outside here. Okay. So that is what we did. And all what we need is this table here for us to draw our histogram. We just need this portion here. Okay. Because you just need the time ranges and your actual frequency. Then the histogram is good as done. So what I'm going to do is to create some space here. Yeah. And then we try to draw our histogram. Okay. So what we are going to do is to quickly make the X's. But usually what is happening is you're usually given a graph paper where you can draw. So the graph paper on the paper that I have was not there. So we'll just need to work with what we have here. Okay. So let me see. Let me make this even to be smaller so that we can have our histogram looking slightly big. Okay. So I just need to have a line, then another one like that. Okay. So let's go ahead and cook, guys. So what we are going to have is we have what, 20 to 100. So we're going to have 20, 40, 60, 80, 100. Okay. That's okay. So 20, 40, 60, 80, and 100. And remember, what we have here is our time. So that is T. And remember, this is in minutes. Okay. And then here at the top, you will see that what we actually have is the number of people. Okay. So what I'm going to say is it's the number of, if you observe carefully, the number of people. Okay. So that is what we have. It's the number of people. So I'm just writing this upside down. And what I'm going to have is we need our scale to get to 70. So we can do 10, 20, 30, 40, 50, 60, 70. In fact, by the looks of things, we can even do fives. Okay. So we can do 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. So let's push it up here. But we don't even need to get to 70 because look at what is happening. Our actual frequency is ending, the maximum is at 24. So we could even be very conservative in this scale and even jump in steps of 2s. Okay, so that we can get to that. So let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. So let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and 26. That's okay. Okay, because the biggest we need is 24 anyway. So let's go and have a look. So between 0 and 20, we have 16. Okay, so what I'm going to do, let's use pink. So I'm going to have 16. So I'm just going to have dots and then go here at 16. Okay, then we are just going to put in a line like that. Right, that is what we have. And then next we look at between 20 and 40, that is at 24. So I'm going to go to 24, go up like that. And then this is 40, go up like that. And then let's look for a solid line, ta-ta, ta-da, like that. Okay, so we have something like that. And then let's go to the next one. So that is between 40 and 60. We have 19. So 19 is somewhere here between 18 and 20. Okay. Then we just go up like that. And we just look for a straight line. And it goes down like that. So that becomes our 19. Then between 60 and 80, we have 8. Okay. Here. 60 and 80, we have 8. So 8 is here. Okay, go up. So let's get a straight line like that. So that is our 80. And then between 80 and 100, we have 3. So 3 is just in between 2 and 4. So that is what we have. So let's put that up. Like that. Okay, so that is what we have. And then we can go ahead, guys, and shade in however way we like. And this would be, our answer. So I hope that it does make sense to you guys. It's very important that you remember that for histograms, we do not use cumulative frequency. We use cumulative frequency for our archive curve, but for histograms, we only use actual frequency. So it's very important that you guys are up to speed with that and you don't make a mistake of using cumulative frequency. Because if you use cumulative frequency, what you are going to see is that your graph was going to look like your archive curve, your histogram. Okay, so that is what we have. And you can probably label this here. Okay, let me just quickly color this one here. So what you could do, you could label. So we have a 3 here, we have an 8 here, then we have a 19, then we have a 24, and then we have a 16. Okay, so that is what we have, guys, as our answer. Now we are required to comment on the skewness of the data. So how is this data? Is it positively skewed? Is it negatively skewed? So let's quickly answer the question of the skewedness of the data here. So I'm going to take an approach that is not so popular, and I'll need you to figure out what you would have done. Okay. So we're looking at answering 2.1.4. So what I'm going to do is I'm going to use Q2. So we know Q2 is half of n plus 1, and we know that our n here is 70. So we have 70 plus 1, which ends up giving us 35.5. Okay. So I need you to note, when we're looking at our cumulative curve, 35.5 is between these values here. Okay. So it is definitely after 20. So it's in this range here between 20 and 40. So if you observe carefully, your 35.5 will be here between 20. Sorry, the value will be here. So which means the range we're looking at is 20, between 20 and 40. So that means our median is sitting somewhere here. That is where our Q2, that is where our median is sitting. Okay. So our median is there. So if you think carefully, if your median is here and you look at your data, you'll see that our data is more on the right of the median. So we can therefore conclusion, which is that this data here is positively skewed. So it is skewed to the right. Because if you observe carefully, we have more data to the right of the median. Others would say this is positively skewed. So this is positively skewed. Okay. So it's very important that you guys are able to make sense of what I'm saying here. Okay. So let's erase this. Now let's go to the next page and see what's going on. Okay. So let's have a look at the next question. So we are told there are 9 players in a basketball team. The coach calculated that on average, each player scored 12 points during the game. The points scored by 8 of the 9 players from the team are given below. Okay. So what we are going to do is to figure out what they're looking for. So we're given 8 of the points scored by the players. So how many players' score was outside 1 standard deviation of the mean? Okay. So we first need to figure out first, what is the other player's score? So what I'm going to do, 2.2, is to start by arranging this. So I'm going to arrange in ascending order. Okay, so what does that mean? It means that I have a 2. But before I even do that, maybe let's calculate the score by the other player. I think it's smarter to start by doing that. So let's calculate the score of the other player. Okay, because my arranging here will just be a problem of the other player. So remember, we're given the average, that on average each player scored 12 points. So we know that the average is 12, and guess what? The average is the sum of the x's divided by n. So we know that n is 9 players. So we can go ahead now and deal with our average. So our average is going to be that the 11 plus 14 plus 19 plus 20 plus 8 plus 10 plus 2 plus 14, and then plus, I'll call this score x, I'll call it sx, okay, like that. And then this is divided by 9, okay. And remember, this will be equal to 12. So we can go ahead and do 9 times 12. So we can go ahead and do 9 times 12. And when we sum on the left, you will see that what we will end up having, that score of player X, and then plus, when you add these numbers, you'll get 98. And then when you do 12 times 9, let me confirm, 12 times 9, we get 108. Okay, 108. So we just now need to transpose such that we find the score. So it's 108 minus 98. And you will see that the score by the other player is 10. Okay. So with this in mind, now we can go and deal with this. How many players lie outside the standard deviation? Okay, 1 standard deviation. So what I'm going to do regardless is quickly to arrange the scores, okay? So let's arrange our scores in ascending order. Okay, so let's see. So if you look carefully, that becomes, if we arrange it in ascending order, it becomes 2 and then 8. So we just found 10, so it becomes 10, 10. Then there's 11, and then there's 14, 14. And then there is, I'm missing an 8. Well, no, I did write the 8. So there's 14, 14, and then 19, then 20. So what do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's what we have. So now what we can do is we can go ahead and figure out our standard. So we need to figure out how many players fall within 1 standard deviation. So for that, we need the mean. Okay. And the mean we are given already. The mean was given as 12. So this is given. So the mean is very important because our standard deviation is given by the square root of our summation of x minus the mean all squared divided by n. Okay, so that is the calculation that we needed to perform. Right, so how you calculate the standard deviation is you can go and use your calculator. So that is what I advise. Use the calculator to calculate the mean, not the mean, the standard deviation. Okay, so if you go ahead and you use your calculator to calculate your standard deviation, what you are going to find is it will be 5.23. Okay, I can go ahead and show you how you find it, but yeah, just use your calculator. So you'll punch in all these data points and then you say shift and you will see it will give you stats, and then you are able to retrieve the standard deviation, the mean, Q1, Q2, and so on. So remember that what we are dealing with is they said within 1 standard deviation. Okay, so that is what we are working with. So if we are within 1 standard deviation, it means we are going to look for data that is an element between, remember it's a deviation from the mean. Okay, so we are going to have x plus, we're going to have our standard deviation plus the mean, then we are going to have the mean minus the standard deviation. And because they are saying 1 standard deviation, it means that this number here, I'm going to multiply it by 1. Okay. If they were saying 2, I was going to multiply by 2. So I'm going to multiply by 1 like that. Okay. Let's make some space here to make sure that we understand that this is just 1 times that. Okay. So we're going to multiply by 1 because they said 1 standard deviation. If they were saying 2, we're going to take the standard deviation and multiply it by 2. It is that easy, guys. So let's go ahead now and look at the x values. So remember, we have 12 plus 5.23, and then we have 12 minus 5.23. So the answer which we end up getting here is, if you do 12 plus that, that's going to be what, 18? It's going to be 17. Check, confirm. 12 plus 5.23, that's 17.23. Okay. Sorry. And this will be 12 minus 5.23, and that will be 6.66. Okay. Let's create some space. So we're going to have 6.77 actually. Right. So now, if you observe carefully, we need to figure out how many players' score was outside 1 standard deviation of the mean. So we need to figure out how many scores are outside this range of ours. So these actually, they are swapped, guys. So I'm supposed to move this to here, and then this to here. So let's fix that. This moves here. You move to here. Okay, let's quickly move that. And then switch the position of these ones also. 6.77. Use it here. And this one goes here. Okay, that is what we have. So now we just need to count the numbers that lie outside this here. So if you observe carefully, you will see that the numbers will be, let's highlight this and come and put it up here. So let me just create some space on this page here. So it's a very simple question that they asked us here, guys. So we look for numbers that are outside this given range here. So you'll see that 2 is outside and 17.29. So 19 is out and 20 is out. So what does this mean? It means we are looking at players because they said how many players' points score was outside this. So that is what we have. So we have 3 players. So our answer here is that the score of 3 players, was outside 1 standard deviation, of the mean. Okay, so that is the answer that we're expecting from us, guys. I hope that it does make sense and you understand what we did here. So take your time, make sure that you are able to do this. But what I urge you to do is please go and make sure you can do this. You can use your calculator to find your standard deviation. It's very important that you do confirm this and you guys are able to do such. So with that said, let's pause here for this lesson, guys. And as always, all these awesome lessons are brought to you by iCampSA. So please do make sure that you share you like. You also invite your friends so that we can work together and hopefully pass together. So cheers, guys. I'll see you on the next one.